Hello everyone, my name is Sri Raksha, student of SVCE from the Department of Computer Science and Engineering. In this video, I am going to discuss about the subject discrete mathematical structure. The topic I am going to discuss is about the fundamentals of logic in mathematics. Introduction. Logic is a fundamental of mathematical reasoning, providing the rules and principles that governs the validity of arguments and the relationship between propositions. This section explores the fundamental concepts of logic, including the basic operations such as negation, conjunction, disjunction, and exclusive distinction. Also, we will see about the important notations of tautology and contradiction. The first one is the negation. It is also known as NOT gate. The fundamentals of logic. The NOT or negation operation is a unary logical operation that reverses the truth value of the statement. The NOT operations take a single proposition as input and output, the opposition of the truth value. That is, if the original statement is false, then the negation statement is true. And if the original statement is true, the negation statement is false. Let's see the truth table. If the original statement, that is P, is true, then the negation of P will be false. If P is false, then the negation P will be true. Next one is about the conjunction or and. The logical AND operation, it is denoted by this symbol, and it is a binary operation that results in truth if the truth output only when both the inputs of the operand are true. It represents an logical AND relationship between the two statements. The truth table of AND operations shows all the possible combinations of input values, that is true and false, and the corresponding output values. It clearly demonstrates the condition under which the output is true. The truth value of AND table shows the output is true when both the input operand are true. In case where at least one of the input operand is false, then the output will be false. You can see here, if P is true, Q is true, and P and Q will be true. If any one of the operand is false, then P and Q will be false. The next one is about the disjunction or operation. The or distinction logical operation is a fundamental concept in mathematics and symbolically represented. It represents a relationship where at least one of the operand is true, but both can be true as well. The truth table of an OR operation shows that the output is true if at least one of the inputs is true, and false only if both the inputs is false. And it is symbolically represented by this symbol, and it is read as P or Q. Let's see the truth table. If P statement is true, Q statement is true, then P or Q will be true. If P is true, Q is false, then P or Q will be true. If P is false, Q is true, P or Q will be also true. If both the P and Q is false, then P or Q will be false. Next one is about the exclusive disjunction. It is also known as XOR or exclusive OR. Exclusive distinction. It is a logical operation that results in true output if only and one of the input is true. Unlike the regular OR operation, the XOR return false if both inputs are true. The truth table of XOR shows the possible combinations of inputs 0 and 1 and the corresponding output. It is exclusive or logical is crucial for building complex decision-making algorithms and solving various fields of mathematics and computer science. You can see in the truth table, if If one statement is false and other statement is true, then the output will be true. If both the statement is false, then the output will be false. The next one is about the tautology. Tautology means it is a statement or proposition that is always true, regardless the truth value of the component parts. It represents a logical necessity, a statement that must be true by a very nature of its logical structure. The truth table of tautology determines the overall statement will always evaluate to true, no matter the input values. This is because the logical structure of the tautology ensures that the condition is true always. For example, let's consider if A is true, then B will be true. These logical statements are always true regardless of a specific value of variables involved, making them an essential tool in mathematical reasoning. You can see here the last output of the table will be true. The next one is about the contradiction. Contradiction, it is a statement or proposition that is always false, regardless of the truth value of its component statement. It represents a logical impossibilities where two or more statements that are logically incompatible with each other and are declared to be true simultaneously. The truth table of the contradiction shows that no matter what the truth value of an individual statement are, that overall statement will be false. This is a fundamental concept in logic that helps us to identify the logical inconsistencies and ensures the validity of our reasoning. Next one is about the applications of logical operators in problem solving. Automation processing. Logical operations like and, or, and not can be used to automate complex decision making processes, and it helps to reduce the potential for human errors. Data filtering and querying. The logical operators are essential for filtering and querying data, allowing you to extract specific information for large data set based on complex criteria. The next application is conditional logic in programming. In computer programming, the logical operators form the basic backbone for conditional statements, enabling programs to make decisions and take appropriate action based on certain conditions. Let's understand about the importance of logical reasoning in mathematics. Logical reasoning is a fundamental of mathematics, enabling us to analyze problems systematically, draw valid conclusions, and solve complex challenges. By mastering the principle of logical operators like negation, conjunction, disjunction, or exclusive distinction, we can develop a crucial problem solving skills that are applicable across various mathematical domains. By applying this logical reasoning to the real world scenarios, further enhance our skills ability to ensure more information regarding the decision making and optimizing the solution. Ultimately, the mastering of the logical reasoning requires us to in learning the powerful tool of negations. Thank you.